Thanks, Mary. And it's an honor to be here. I guess Justin and I were in the Fellows program, as we mentioned, and that's how this mostly started. And also a lot of the interest stemmed from trying to best advise our students in electrical engineering and to mentor them along their path, and to also help in recruiting students to the area and identifying who best to recruit. So I know we have a fairly broad audience here. How many are engineers? Very few, right? So we have a very broad spectrum. Well, if you look at the people coming into electrical engineering, well, they're not engineers yet. So we have very much the same sort of challenges. Let's see here. So question is, what is engineering? What is electrical engineering specifically? So I want you to take a minute, maybe close your eyes, or think about what do you think an engineer does, and specifically what do you think an electrical engineer does? I'd like you to sort of burn that in your mind. Take a second and think about it based on your interpretation. And when I ask freshmen, one of the things that usually pop in their mind of what an engineer is, they look at this guy. And they think of it, an engineer, it's the person who runs the engine, right? But that's not necessarily true, and a lot of students come in with that perspective. But actually engineer, I'm not a linguist, or I don't know Latin very well, but my understanding is engineer comes from ingenium, meaning cleverness. So actually we're problem solvers. So it's actually a very different perspective than a lot of students actually come in with. So how about electrical engineers? What kind of picture did you actually have in your mind? And a lot of them actually come up with this guy. And well, that can be what an electrical engineer looks like or does. You know, the guy that has the computer card with the chips on it and so on. But a lot of our students, well, how do we actually recruit students when they don't even know what the field is? And even once they declare electrical engineering, they don't even necessarily know what electrical engineering is all about. So it's actually a much broader thing. So we're trying to, no offense to people in the area of English, but we're trying to avoid this issue where they don't know where they're getting into. We want to be able to recruit, find out people who have strengths or interests in that area, and to be able to help them along the way. So just as a brief overview of electrical engineering, these are kind of the four areas that, these are sort of the four areas, this animation I didn't know about. There are actually four areas that I'll sort of group things into. One is circuits and solid state, which are really where you have a bunch of devices that deal with electrical signals or optical signals and associated circuits to accomplish something. We also have a more specialized area, computers, where they actually deal with all these components together and also crosses over with computer science so they can program these things. So this one's fairly physics heavy. This is sort of a mixture of like physics and like software programming, those kind of things. We also have electromagnetics and optics, which a lot of people don't think of as EE necessarily. That's fairly physics intensive and involves, say, plasmas in this picture here, lasers, radar, those kind of things. And also we have this other area that very few people think of as EE, and that is an area of control, signals, and systems, which can involve things like robotics, control systems for that, signal processing when you're dealing with communications, and also imaging, even biomedical applications such as imaging. That also is truly an EE sort of field. So the question is, how can we actually recruit students into EE, and once they're in EE, how can we advise them into which sort of subdiscipline they should go into? And this is really where analytics sort of plays a role. So what we started doing is looking at data of student records over the past 10 years. That was what really started with the Learning Analytics Fellows program. Also starting to actually get a little more qualitative data or direct data through focus groups, and to also start to construct surveys of students and alumni. And eventually we'd like to do more, look at more data through LinkedIn, for example. We have one of the largest alumni populations for a department on LinkedIn in electrical engineering. So eventually what we're hoping to do is to eventually have some sort of model like this where we take student input, where we have their academic record, interests, and activities as the input, as an engineer, we always think of input and output. So we have input here, and the output, we'd like to have areas of study, things they can consider in their academic path, what they might consider for careers or suggestions for professional or graduate school, and extracurriculars they might be interested in. And what we need to make that happen are essentially these predictive models or correlations that will predict their success or match their interests and skill. And that's where the analytics comes in, is trying to develop these sort of models. All right? So we've started looking at those correlations, for example, specifically on courses, what their grade is relative to their final graduating GPA, just to sort of see how strong correlations are. And essentially here, for example, if we see our first required circuits class has an extremely strong correlation on what you ultimately graduate with. And this is one of the nice things of plotting that we learned about in the Fellows program. So we continue to look at that in a series of courses. We can see strong correlations in most places. In our EECS 280 programming class, we actually see strong correlation, but essentially we see a shift down, which tells us we have a so-called, say, grade penalty, where usually everyone's getting a much lower grade than they ultimately graduate with. And also cases here where we have just high grades across the board. This is what we call our major design classes, their capstone design, where everyone usually gets a pretty high grade. So that's kind of expected. And we sort of confirm that by looking at average grades of major designs. They're all relatively high in the B+ to A- range, and our required classes are generally have fairly low average grade points. All right. So if we go back and look at those correlation coefficients, yes, we do see fairly strong correlations across the board. So what that tells us is maybe, well, a good student's a good student, bad student's maybe not such a great student. Can we learn anything of value to help us offer some advice? So we started looking, again, a little more carefully at this by dividing among the subdisciplines within EE. So I mentioned we had those sort of 4 areas in electrical engineering. So we started looking at those, the circuit, solid state, computers, electromagnetics, optics, signals and systems. And also we had this other, which was if you take a design outside of EE. That's often if you do some mechanical engineering or some larger scale project. All right? So those are a little more difficult to track. And what we see is in general, yes, some of these classes like calculus, essentially they're all very strong predictors of what you finally graduate with. But there are some classes where you do see some of these shifts or offsets. In one case, programming, for example. So this is the class I mentioned. There was this grade penalty where everyone usually gets about a half letter grade lower than they graduate with. And we see that across the boards, except in computers. Real surprise, right? So these are strong programmers, so they get about a half letter grade better than the other students. So there are other sort of correlations. And particularly, we'd like to look at differences among groups. And after trying to learn a little bit of statistics, and thanks to help from CSCAR, we learned about the ANOVA sort of analysis, where we can try to determine statistical significance and comparison among groups. And we did see cases where we have fairly strong significance, or p-values less than 0.05, so we have some confidence there. And here's just a summary of those. I'll take you and maybe describe some of these in a little more detail. So if we look at those students who took these designs outside of an EE-related field, we actually saw that in general, they always had a lower grade in our first-year circuits and first-year electromagnetics courses. So in general, they're all doing much worse, and we have fairly strong significance. So we have the y-axis, which is the mean difference. That's their average relative performance in EECS 215 relative to, for an other MDE student or someone outside of EE, relative to circuits, this person relative to computers, relative to optics, etc. All right? And so in general, the students were all performing at a lower level if they chose something outside of EE. And we had strong correlations. That's the significance on the over here. And if you're below this dashed line, that's significance of 0.05. All right? So same thing for electromagnetics. We see fairly strong confidence, all significance below or p-values below 0.05. In general, they're all doing worse in electromagnetics. So what does that tell you? Well, really, it's saying that, well, if you're choosing something outside of EE, maybe EE is not your strength, so maybe you didn't learn a whole lot. So we'd expect, well, maybe we'd see this for the other ones as well. Let's say you take someone from signals and systems, which is a fairly math-intensive area of EE. You would expect, initially, that they would do much better in the first signals and systems class, that's math-intensive, and also the probability and statistics class, EECS 401. It turns out we don't see a strong correlation. So that was something, learning analytics is pointing to something that we need to investigate a little bit further. So there is not a strong correlation necessarily between these courses and their choice to eventually go into signals and systems. So that's something we're trying to figure out or look into a little further. Yep.
When do, in the curriculum,
yeah.
freshman through senior year, do students take these classes, and when do they sort of declare their specialization?
So they never actually declare a specialization, so that's what made it tricky. What we did is based it off of their final choice of senior design area or project. Gotcha. So they're sort of just self-selecting based on their choice of courses. Gotcha. So ultimately, though, this can help us. We were surprised to see that there's no predictor here, but there was in the other case. All right. And we actually see, not surprisingly, in the area of computers and circuits and solid state. If you look at those classes, computer programming, we have EECS 280. We see across the board a much better score in EECS 280 with fairly high confidence that they're going to do better in programming, that they're eventually going to choose something in the computer-related area. Same thing for circuits and solid state. If they did well in this introductory, the semiconductor device class, which is more hardware physics-based, they're going to do better there in comparison to the areas of E&M and optics, computers, signals, and systems. All right, by maybe an eighth to a quarter letter, or quarter to a half letter grade. All right. So just a summary: when we look at the subdisciplines, some of the required courses serve as predictors, particularly in computers, solid-state circuits, and people taking classes outside of EE, but some do not. So what we really need is more data beyond grades, and that's what we've started to look into more recently. But the question is, how do we get that data, or what do we look at? And so we want to get more, say, qualitative data that we can quantify, I guess you would say, by using survey data. In particular, we want to get feedback from these different groups of students, people who are not yet declared, recent declares, people in the middle of the program, and then seniors. But we need to be able to design a good survey. So that's where Shanna has been of great help in trying to help us guide us in this process, because that's something we're not well versed in as engineers. And Justin has done a great job of operating these focus groups, or organizing these, and getting data from students among these different groups. And to do that, or some of the key outcomes is that, one, the role of a good instructor cannot be overemphasized. So even though we have these analytics about class performance, what we really need to look at is maybe it's just a singular faculty member that is really influencing their final decisions. So understanding that is very important. Another is that, real surprise, job prospects are actually guiding their decisions in many cases. So what they perceive as a great job opportunity after graduation, or their values, are going to eventually influence their decision. So one is, well, whether or not when they want to go to grad school, EE careers seem to be, from our students, that EE careers are perceived to require grad school, which is true in some cases, and some subdisciplines in particular. And also computer science positions are in a large demand. So one thing we've noticed is that EE has been very flat in enrollment over the years, but computer science is just skyrocketing right now. So this could be very much, well, not surprising, I guess. So based on some of the focus group stuff, we've been sort of designing surveys based on this. So of course we need to make sure they're valid and reliable to try to give us some information. So the first step we're doing is to construct what we have our exit surveys. So whenever a senior is going to graduate, we'll give them this survey. We've been doing this, but it was not necessarily a well-designed survey. So we're rolling out a new one for the graduates this year. It'll be part of their senior audit, so we can sort of ensure participation. So we're not necessarily going to make sure, offer our services to make sure your stuff is done unless you actually think of doing the survey. And we're also planning to design and issue another one to all College of Engineering students across the board, so we can get information from like new declares and people in the program currently. All right. And so what are we going to do with the survey data? Well, this is where we hope that analytics will help us to get some more information. So first, I should mention that we're designing this survey. I'm not going to show you a copy of the whole thing, but it's based on some past work published in ASWE and also the Journal of Information Systems Education, where they were really looking at students and how they choose their various engineering majors. All right. So eventually, when we get those, we'd like to do is do a regression analysis and try to look at various dependencies, essentially dependent variables being finally choice of subdiscipline, job placement, grad professional school acceptance, confidence, overall satisfaction, et cetera, not just the graduating GPA, which is all we've looked at so far. And the predictor variables, we have a series of things, not just course performance, but also things like age, gender. We're looking at things like parental education. What is the history? Do you have parents that are PhDs, or are you the first-time college grad, for example? That may play a role. Prior awareness of engineering. What did you think an engineer was when you came into school? Were you knowledgeable about that or not? What sort of activities did you do on campus? Did you join societies, get involved in projects like Solar Car? Did you do an internship or co-op along the way? Research? Did you receive awards and scholarship to sort of motivate you and keep you interested in the program? So that's really our what we're planning to do or continuing to work on this semester. So in conclusion, I think we have some strong correlations observed between required courses and graduating GPA. But the question is it a good student, or is there something else going on? But we started doing some comparison of relative performance among various subdisciplines. We do see some interesting results that can help us potentially advise students on different paths. And right now we're focusing a lot on survey information to try to identify how people are choosing these subfields and how they're successful. And finally, I think what we really want to do is look at the truly long-term stuff. That is, what are people doing after graduation 5-10 years? And that's where we really like to connect with alumni. And that's going to be a real challenge. LinkedIn can help us, but we also hope to have a stronger connection with alumni. And finally, I'd like to thank the Learning Analytics Fellows Program and the Exploring Learning Analytics Program for their support of this, and also for CSCAR for their help on guiding some of this analysis. So, thank you.
So this is 11 plus 1 reasons why we created Grammar Podcasts for high beginners in elementary Spanish. First of all, I'd like to introduce the first one. Later on, I can tell you what a high beginner is in elementary Spanish and go by each reason. And I say plus 1 because there are some hidden reasons that you cannot predict. But then after all, you say, yeah, this was a good idea to do. And this is one of the projects that I developed with the MELO, the Michigan Education Through Learning Objects. I integrated the group in 2010 with my team. This is Marcelino and Maria. We started creating this through the seeing the exciting learning objects that we're creating in other disciplines such as psychology, chemistry, statistics. We started to think, what can we do and where do we need these learning objects? So the first reason is to create this grammar podcast is because all of us are different. And A high beginner of Spanish is someone who has taken Spanish in the high school before. But this may mean just 1 year, 2 years, or 3 years. So you all have taken just 1 year. You've taken 3 years. Maybe you transferred to the University of Michigan and you took 1 semester in a community college or somewhere else. The rest of you have taken 1 year. So you can see that disparity here of Spanish levels that we have. And the Spanish 103 is a course that is designed, it's still a 100 level course that is designed to kind of level up the students in the same, getting them ready for Spanish 231 for second year Spanish, but still there are topics that are more difficult than others, and we identified those themes or those topics, and we focus on that. The first learning object that we designed, that's not part of this presentation, but I'd like to mention, is the segments, movie segments. So we took movie segments to start to further practice in imperfect and preterite. 2 different topics that we use in Spanish to narrate in the past. Those are difficult, and we saw that a lot of students were coming to our office hours, one after another student waiting outside, and it wasn't enough for us. So that was one of the topics that we designed those learning objects, but there were some other grammar topics that still needed to be addressed. And that's where the grammar podcast started to kind of shape in our minds. But still, and even when the students came to our office hours, they were still trying to figure it out. And they had to go to a website, try to look up for imperfect and preterite, or double pronouns, or indirect object pronouns, different, and those are difficult concepts for students to grasp. And we also noticed that technology is in your hands. So we needed to start using that. What did we do? We designed the grammar podcast. This is actually one of my students. And just to talk a little bit less, and we can go ahead and visit the site that I created with some of the grammar podcasts. So this is the site, and I always use the image, the personal image resources, and we're going to visit Unit 4, and I like this one a lot. Around this time? Now, no? So then, that's Tati talking in English. That was important because the class is in Spanish. So that's she talking in English, going over the grammar using a PowerPoint presentation, and using, many people use Camtasia, I use ScreenFlow. There is also Jing that's used, and it's a free resource on the web. So that is there. And students do like it. We're gonna see later on what the students say about that. Okay, so there are more that we cannot see now. Now let's go to the 7th one. So with this, the students had this first on C-Tools. I hadn't created this when Steve and I did the analytics of the use of this podcast. But later on, I created the website for the public at large. It's not showing. Okay, students can practice at their own pace. Yeah. And it was there for them. And it's good to know that students are also reflective about all these resources. Later on, we're going to read one of the comments that one student made about these resources. So it's there for you. I'm using the vocabulary that we use in class. I use the same terms that we use in class, just in English. And here is where I need help. Because I'm not very familiar with numbers. I love to create learning objects. I love to be creative. I am creative. But then the next step, when you do something like this, when you create something like this, is it working, or is it just fun for you to work and just put it out there? No, we needed to know if it was working for students. So I received a lot of help from Steve Lund, and I'm so happy that you're here, Steve. We designed a survey using Qualtrics that very luckily all of the students, the 70 students that were taking the class I was teaching, and they took, just because it was extra credit to have to complete the survey. And also Steve pulled out data from C-Tools. And we saw how many times the student watched the podcast over a certain period of time. Now, we need to make clear that how many times the student watched the podcast is very hopeful, because they can just click, open the podcast, but not watch it, or save it for later, or the 4 times that we saw over 2 periods, over 2 weeks, maybe they just clicked, maybe they were hopeful to have the time to watch it. So, but based on and using that, those data, we concluded this. And also we gathered information from that specific grammar point the student was watching and the test results. So I sat in my office, flipping pages, getting notes, and getting all these numbers to put together. The survey, the number of times that they opened the podcast, and the results on the test. Comparing them also to tests before that semester without the grammar podcast. So first of all, we have the student. Is this? See, that's the A student. We can identify this student as an A student by his performance. This student here is also a good student, but his performance is not at a high level. And this is the C or D student. It's difficult for him, maybe because it's difficult. He doesn't put all the effort into it. So, but that's the performance that we identified before. This student maybe didn't watch the grammar podcast or once, and still he got an A. The B student, difficult material for him, watched it. We counted, the maximum times that we counted was 5 times. And he did improve. At least in that section of the exam, for that grammar, he did get an A. This student, we even noticed students opening the grammar podcast 10 minutes before the exam. So that is also telling of the study habits. And still, or watch it just once, or open it just once, and he still was just like before. Nothing happened, nothing modified his performance. Now, we also gather information about if they were using them, and you can go ahead and read. Okay, so they wanted more podcasts. They were very helpful, and the other one says it might be good if there was required homework for the podcast because they were very beneficial. I'm not sure that everybody even knew about the podcast, and this is true. By then, this was 2011, first semester, winter semester. They were on C-tools, but they weren't very emphasized. And then later on, using the results that we just saw, they were more emphasized, and they are also on the syllabus, so that students can go ahead and prepare also, like to flip the classroom in that sense, or use them at their own leisure. I think the podcasts were very helpful because they were short, sweet, and straight to the point. And I think the podcasts and worksheets in class were the most helpful. The podcasts explained each concept in simple terms and provided slides to go along. So that's also good. Now, we also, for the later podcast, we started integrating more grammar exercises. So we tell the student, just pause here, have your answers ready. Are you ready? Click, continue, and we see the answers there. So just short instruction there. And I love this. The next one, the next quote is that students do become reflective about their own learning. And one student says that, I think the podcasts and other resources were good. It is just how much us students are willing to practice in order to grasp the particular concept. So at least this project also makes them reflect how they're going to use their resources. Now, you want to do more, it's just one after the other and say, hey, but we have students with just 1 year of Spanish, even the simplest grammar topic that we can think of may be difficult for them. So there it is. More, or to plan more learning objects. And this material, this is the perk, kind of. This material is in the Open Michigan Educational Project, so it's open to the public as well. Thank you.
Hola, ¿cómo están? Yo me llamo Tatiana Calixto. Estoy aquí para explicarles más de el subjuntivo. And no worries, this is going to be in English, okay? So let's go on and talk about the subjunctive. We're going to start by seeing what the subjunctive mood is when we use it, the conjugations, irregular verbs, spelling changes of some verb, the triggers, and some examples. So let's start out with what is the subjunctive mood. We need to make some distinctions here between what a tense is and what a mood is. Tense, let's see some examples of tenses. It's the present, the preterite, imperfect, present perfect. And these refer to when when an action happened. But we have a mood. We have the indicative mood that we've seen so far. The indicative indicates. So let's say some examples of this indicative mood, such as mi carro es rojo, it is red, cannot change that, and I'm telling you a fact. See?
Okay, that's it. Now, in making the website for today, the feed for today, I was also seeing how students, and even me, are getting used to the scrolling down and down and down and down. So maybe that might be another future learning object in that format as well. Because sometimes when I'm on Facebook and I open something, and if it's not like the bullet point or the number 1, 2, 3 reasons, like, okay, I'm gonna read that later. So maybe we're getting to that point as well. Okay, thank you.
One thing I'll say is it seems like among, at faculty meetings and also in talking to students, there's always a lot of perceptions in our different fields, right? But we're in an age now where we have so much data at our disposal that we can learn a lot and make more educated decisions than we often do at faculty meetings, where one person is very, outspoken about something and can convince you of something, but it may not be backed up by something that is real, data or other things. And also, but not just to rely on that data, but to really make sure you back it up with communications from real people, students, faculty.
Okay, excellent.
Oh, sorry. I had a question about that, and the amount of data you have. I'm thinking many of us in this room might be envious of the number of students you have and the quantity of data that you can pull these relationships from. I guess, I don't really know what my question is. Well, can you at least tell us what the scope of your database was? Were you working with thousands of data points?
We were at about 1,000, I think, over the course of the graduates of the past 10 years. But I think it's going to be more difficult as we look at the, say, senior exit surveys, because we only graduate, say, around 100 in EE specifically a year. So it's going to take a while before we have enough data to work on. So that is tough. But I guess that's where statistical analysis can help you with the confidence levels, and it takes into account those numbers.
So Shanna, I think you were going to speak to the earlier.
Oh, I was just going to add, in terms of thinking, sort of, how does this apply across disciplines? I think for us, we knew that there were some factors that were going to sort of relate and play a major role, but we really opened it up and said, what other factors are there that we're not considering? And, the factors are measured in different ways. Some of them are the number that we can pull from the, database. Others are ones we're discovering in focus groups and then trying to translate that into a question that we can ask on a survey. And I think we're realizing it's really this culmination of factors, and we're not sure which ones are the most important yet, but we're acknowledging this broad scope of possibilities before saying we think it's this. And I
So the
think that's
UMF data warehouse may not be enough then to explain what's going on.
Right.
Okay. Other questions?
Good question on the Spanish issues. So how did you identify the topics for which you wanted to create podcasts? How did you identify what you thought were the most difficult concepts for this diverse group of first-year students?
Gathering data was very anecdotal. It was just a bunch of students outside that I really had to step out and say, who comes here for double pronouns? Okay, you just wait there. And there were like 5 people in my office. Really, it was just sometimes the office hours were not desolated, but there were times like imperfect and preterite, subjunctive, double pronouns, in something other pronouns. It was then. It was just by seeing all the students outside your office. And it did decrease the number of students who came. There were some, but not a lot, as in previous semesters.
A related question is, are the students pretty good at figuring out that they need to know about whatever these topics are? Do you feel?
What do you mean?
If they come to ask you about double pronouns, is that really an important thing? Are they able to figure out what are the important questions that they're struggling with? the reason I ask is because when you put the podcasts out there, then somehow the students have to figure out that these are the ones that are, appropriate for them. And I'm trying to imagine, how do the students identify that, yes, this podcast is worth watching. This is probably, for these podcasts here are the important ones for me next.
I'm not sure if I'm going to answer your question, but this is required material. They need to know that. Second, the instruction in the classroom is in Spanish. So maybe it's not a matter of identifying, but needing to know that material. And if there is a student who's still struggling, a good thing is just to go watch the podcast because it's in English. And it's like taking you by the hand. Actually, no, it's super easy. In the classroom, they need to read the grammar before, study the grammar before, come up with questions, and we practice. They may still struggle in the classroom. So, does that answer your question? Okay.
I also, Steve may want to speak to this, because you may see things from the use data to make sure that students who need these resources.
Well, and Tati spoke to that. I think one of the surprising things to us was identifying when students were viewing the podcast and which students viewed it clicked on it multiple times. And I'll say in the 2 years since we've kind of done this research, we've also, as a university, moved to a central system that's it's called Tailor. It's a video content management system. So now we're able to go in and see, okay, when did you click on it? What's the drop-off rate? How much did you watch that video? And so we can do a little bit more nuanced analytics, which I started pulling out for the first time yesterday, and it's okay. But it's a start. But now the other thing I'll say that I think speaks to Mary's one of your original questions was that across the Mello project, we saw very often that these master instructors started seeing, we talked to, I think the previous Mello talk about cross-pollination across, and we saw a lot of this identifying where common misconceptions are, where common mistakes are with students, and really designing learning objects and designing materials to really address those most common misconceptions, saying, you really need help in understanding subjunctive, or in Brenda's class, you really need help understanding what the heck a mean is. And it's those core financial pieces that even in the upper division classes, you still sometimes you return to it like, how do I find standard deviation? What does that mean? Which is, before you go into detail.
Yeah, thanks for adding that. So figure out what the bottlenecks are in your class.
I guess I had a related question to what both of them were asking, and that is, what were the podcasts that were watched more often? Because that could go and feed back into your curriculum and say, this is the problem areas, which I think was kind of the question he was asking. Were you able to identify that kind of a pattern?
The pattern of, sorry.
Were there certain podcasts that were watched more often? I mean, did you have like multiple podcasts and then the students access certain podcasts more often or watch them multiple times? Because as an instructor, that gives you useful feedback that may be the problem area.
That's a good thing to look into. And not all the grammar topics are still podcasted.
Sure. But whatever you have.
But this is something that I want to do. I have one podcast that, I do linger and repeat and even nag. Like, this is what you need to know, blah, blah, blah. One podcast right now is like 20 minutes, and I say, no, we can't do that. So another member of the team is Martin Vega, and he's very straight to the point. So we're gonna see. I'm gonna finish the one that I have designed and ready to record, and he's gonna make his on the same topic. So that's gonna be interesting.
Thinking that you have different levels of Spanish readiness in your classroom. What podcasts are being accessed by the different levels? That
Exactly.
might be very critical in
Yes.
having a good curriculum.
Yes. Yes. Thank you.
So you mentioned it's open to the public. Are you seeing people outside, widespread usage of other people? Or is it mostly just your students that?
I cannot tell if someone is using the website. iWeb, when you use iWeb, there is something called help me please, when you can get the data where the IP addresses that people are visiting your iWeb is not a good software. So I don't know who's using that. But I was contacted by someone in University of Maryland, I think it was like the beginning of last semester, and she's doing her dissertation on OER, and so she wanted to interview me or something. So that at least means that people are visiting, that they are aware of that material as well. Yeah, CES, SES, system something, embedded data. But you know what I'm trying to understand, to explain.
Yes. And if not, I'm going to end with one for Jamie.
Okay.
I know you're beginning your research with the survey, but what's your sense at this point about what the biggest push and pull is to students choosing an electrical and engineering and computer science concentration?
Well,
Your gut sense of the top one or two factors, attracting them?
they would attract them, or actually, Justin, since you did we both have our perceptions.
So, do you mean the subdisciplines within, or just people who
Coming in the first
By and large, most people know that they want to go into electrical engineering before they even step foot on UM soil, and to me, it's not completely clear where this driving force is. A lot of people are just interested in, let's say, computers, or they did robotics in high school. One question I asked was, are your parents engineers or electrical engineers? And I'd say less than 10% had anybody associated with even engineering in their family. So people come in kind of knowing what they want to do. And then beyond that, once they get here, different classes can really play a huge role, because faculty, I actually heard that specific faculty drive students to go towards CS or towards even, like, let's say, circuits. And so I think that going into UM being an electrical engineer, I think that it's what they've already had an introduction to, and then once they're here, it could be largely based on faculty, or some people are in student organizations where they're forced to learn how to work with microcontrollers, and that can really dictate or suggest a direction for them to go.
So I think, just adding on that, I think that's one of the real goals of this project, is to try to identify those features so we can reach out to students who may not have ever thought of electrical engineering. They could be in LS&A, they could be in maybe consider engineering, and to try to say, hey, have you thought about this? Because based on what we know about you, this might be a really good option, a really good choice.
That was going to be my follow-up question. What success would look like for the project? Would it be identifying students that currently don't know about EECS and get them into it, or perhaps identifying students that are ultimately not going to be successful and giving them some advice early on? Sounds good.
Yeah, so both of those, as well as once they're in the program, trying to efficiently guide them through according to interest, rather than them taking some classes and then later realizing, hey, I really want to go this direction, but now I've got to take all these other classes and I'm going to take another semester or year to graduate. So, and also to place them beyond graduation. So